Okay, so this is the problem number 2 on page 3 of the chapter 4 test review packet. Okay, all right, so DE is an altitude and BF is an altitude and AF is EC and AD is BC. Okay, and you want to make AB is congruent to DEC. Okay, so you probably have to make these two triangles congruent to make it a CPCTC. It could be this, and then looking at it, these are congruent, so you can make these congruent. So you can make these two small ones congruent by HL, by hypotenuse leg. And once you do that, yeah, you can make these congruent, right? These are congruent. And these are congruent, right? These, the AF and EC are congruent. And this is, so that's angles, side angle side to make these two triangles congruent. So the AB is DC. Okay. By the way, I don't like this. AB should be CD. Alright, so let's start with making two small ones congruent. So I'm gonna start with, I like to start with tougher ones. AF is congruent to EC, and that is given. And so, AF is AE plus EF, and EC is FC plus EF. So that's segment addition postulate. Oh, and you can do this. AF equal EC. I told you can put that in the same line now, right? Sorry. Since AF equal EC, you can set these equal. So AE plus EF equal FC plus EF, and that would be wait, these are equal, so you're setting them equal, so that would be substitution, right? Yeah, this AF, use a double substitution actually, so this is going in here and this is going in here, right? It is no addition property because you're not adding the same thing to the both side of the equation. That's a substitution. Property of 1 and 2. Okay, and then EF equal EF. That's a reflexive property. So you can make it AE equal FC, or AF is congruent to FC, and that is subtraction. Okay, so now we got the side. And then let's get the angles done. So DE is on altitude, BF is on altitude, that's given. So angle BFC is right angle. Angle DEA is right angle. That's definition of altitude. And 8, triangle BFC and triangle DEA are right triangles. Definition of right triangles, right? So actually, so this is known as, because we're doing HL, that would be a leg. And you have R, so now we need a hypotenuse, and that's this, and that's given. So AF is congruent to AD is congruent to, it should be CB. Bad problem. CB, and that's given, and that is a hypotenuse. So triangle AED is congruent to triangle CFB, and that's HL theorem. Alright, so now we can say that DE is congruent to BF. DE is congruent to BF by CPCTC, and 12 angle BFE is congruent to angle BFE and DEC, and that's definition of altitude, right? Did we say we did the right angles? Okay, so it's not a definition of altitude. We have to make them right angles first, because that's a definition. Can't put them in congruent right away. You have to make them right angles. Alright, so angle, we want this and this, right? So DFA and angle, no, not D, B. BFA and DEC. DEC are right angles, and that's the definition of altitude. So angle BFA is congruent to angle DEC, and all right angles are congruent. So I got the side and angle, and then now this is given. AF is congruent to CE. Yes, but CE, and that is CPCTC. So these two triangles are congruent. Triangle AFB is congruent to triangle CED by side angle side portrait, and therefore AB is congruent to CD by CPCTC.